Graphs of logarithmic functions, example 2. Consider the function f y equals e to the power of x minus 3. In part A, find the equation defining the inverse function. Okay, so let me start part by part. This is part A. We have the function f given by the formula y equals e to the power of x minus 3. Now, if I want to find its inverse, what I do is I interchange x and y variables in the formula to obtain x equals e to the power of y minus 3, and in what follows I will try to express y as the variable. So, to do that, what I can do here is to take natural logarithm from both sides of this equation. So on the left-hand side, I get logarithm of x equals, and on the right-hand side, I get logarithm of e to the power of y minus 3, which actually is nothing else than y minus 3 times logarithm of the base e. So since this is 1, because the natural logarithm of the base is 1, we end up with the equation logarithm of x equals y minus 3, and this will enable us to express y by adding 3 to both sides. So our equation for the inverse is y equals logarithm of x plus 3. And here it is, here is the equation that we wanted. So this was the original function, and here I have the inverse. So the original one was the exponential function, and the inverse is the logarithmic function. In part B, we are asked to sketch the graphs of f and f inverse on the same set of axes. Okay, so to do that, I have prepared here set of coordinates. So let me call them x and y. So this is the x-axis and this is the y-axis. We have numbers 1, 2, 3, 4, and so on. 1, 2, 3, 4, and so on. Now, what I need to do, I need to sketch the graph first of the function f, which is y equals e to the power of x minus 3. So there is the relationship between this function and the function f sub 0, y equals e to the power of x. So this function e to the power of x, actually, it can be found here on the graph. It is there already, I have prepared it in advance. So this is the green function, this is e to the power of x. Now what I need to do is to shift it, or to translate it through 3 units to the right, according to the fact that this can be understood as the function 1 times e to the power of x minus m plus n, where n is 0 and m is 3. So it tells me by how many units to translate the graph. So it tells me actually to translate this green graph by 3 units to the right. So what I do, I will translate. So it's 1 unit, 2, 3 units. Okay, by doing that, I obtained the new graph, and you see that there is this original one in a different shade of green. So let me call this y equals e to the power of x, and this one should be y equals e to the power of x minus 3. What you can observe here is the following. This point here, which had the coordinates of 0 and 1, is translated to a new position with coordinates 3 and 1, and moreover the point with coordinates 1 and e, this point, this is approximately 2.7 and so on here on the vertical axis. This is translated also by 3 units to the right to this new position. So the green function is the function f. This is the function f. Okay, let me denote it. Now let us talk about the graph of the logarithmic function. So we need the function f inverse, which has the equation y equals logarithm of x plus 3. So you see, this has some relationship to another function. Let me call it f inverse 0, sub 0, which would be the function with the equation y equals logarithm of x, natural logarithm of x. And this is actually here on the picture in the blue curve there. So this is the function y equals natural logarithm of x, and you can see that it really is, it passes through this point with coordinates 1 and 0, and it passes through the point, through this point here with coordinates e, which is approximately 2.7 and 1. Okay, so this logarithmic function should be translated by some distance, and you see actually that it has the form 1 times logarithm of x minus 0 plus 3. So this is m and this is n. So I don't have to translate it in horizontal direction, but I do have to translate it in vertical direction. So this is exactly what I'm going to do. I'll just take it, this curve, and shift it or move it by 3 units upward. So 1, 2, 3. Okay, by doing that, what I obtained is the new graph. So this function here is the function y equals a logarithm of x plus 3, and this is the function inverse, the inverse function to the green one. And the original logarithm is in a different shade of blue. It's there on the original position. Now you see this point here with coordinates 1 and 0 has translated to this new position 1 and 3, and this point has translated or has been translated to the new position there. Okay, so these are the two graphs, and perhaps it should be it for this part of the exercise. So this was the part B of the exercise, as far as I can remember. Yes, we had to sketch the graph of both functions on the same set of axes, and this is what we did actually. So here it is, you can see both of them in different colors. So blue for the logarithmic function and green for the exponential one. Okay, now in part C, we have to state the domain and range of f and f inverse. So let us look at the graph and try to do it. So let us concentrate on the green function there. So the domain of the green function, of the function f, you can see it, is the set of all real numbers. But since the green function is the inverse of the blue one, it must be at the same time the range of the inverse. So the range of the inverse function, you can observe it yourself, the range of the inverse function is the set of all real numbers. As for the range of the original function f, you can see it yourself that the original function, the green one, takes on only positive y values. So we would say that it's r plus, like the set of all real numbers which are positive or greater than 0. And you can see that this is actually also the domain of the inverse logarithmic function. So the inverse logarithmic function has the domain also consisting only from real, positive real numbers. Okay, so this is for so much for the domain and the range of both functions. Now in part D, we are asked to find any asymptotes and intercepts of f and f inverse. Okay, so in part D, this was part C, okay, and now in part D, we are going to concentrate on the asymptotes. So let us look at the function f. Okay, the function f, the green function, does it have any asymptote? Well, you can see it yourself that it approaches x-axis without any restriction, but it never touches it. So I can say that the x-axis is its asymptote. So it's the asymptote y equals 0. This is the equation of the x-axis. So this is the asymptote, and we say that it's horizontal asymptote. Now, as for the intercepts of green function, you can see that it never crosses the x-axis, and therefore it can only have y-intercept. And the y-intercept here, this position there, okay, can be obtained by setting x equal to 0. So if I want to find the x-intercept, the y-intercept, I set x equal to 0. This is the y-intercept. I set x equal to 0, and I use the formula for the function, which is y equals e to the power of x minus 3, okay? And what I do, I substitute 0 for x, so I get e to the power of 0 minus 3, so it's e to the power of negative 3. So it will be a small number, positive, but less than 1, and therefore I see that this must be it. It's e to the power of negative 3 here. This is the vertical axis, or the y-axis intercept, or y-intercept of the function. Now, since the blue function, the logarithmic function f inverse, is related to the original function f by the fact that it is its reflection on the diagonal of the first and third quadrant, so this line y equals x, so it is just the reflection. So it means that if, for example, the x-axis was the asymptote of the green function, then the image of the x-axis must be the asymptote of the blue function. Okay, so if I reflect x-axis on this axis, y equals x, what I get is the y-axis, and you can check it yourself that the blue curve approaches y-axis without any restriction. It approaches it but never touches it. So I can say that the line x equals 0, which is the y-axis, is the vertical asymptote of this inverse function, of this logarithmic function. As for the intercepts, I can see that since the y-axis is the asymptote of the blue function, the blue function never crosses it, never has no point which could be understood as the y-intercept. There is only the x-intercept of the blue curve, and it appears here in this position very close to 0, and the x-intercept should be, if you think about that, it should be the same as the y-intercept of the original function. So it should be x equals e to the power of negative 3. And the reason for that is that this point here on the x-axis, this intercept point, is the image of the intercept point of the original f function on the y-axis. Okay, so this should be it. This closes this problem. We have already answered all parts of it, and yeah, and this is it.